Okay, let's continue with part two. Here we have again our home. We have 30 years. We have monthly. So 30 times 12 will be your end value. And 30 times 12 happens to be some number 360. Interest value again is given 6.5. Present value, you're going to still enter this in as a negative value, negative 158,000. Payment is what you're calculating. I'm going to put a question mark there. Future value, that's going to be 0, because whenever you make a house payment or car payment, it's like you're taking your mountain of $158,000 and you're just paying it down. You're taking a little bit off of it every single time, and that's how you make house payments and car payments. Your future value is going to then be 0 because there's nothing left at the end, and 12 here, and this should be 12 as well. And then you would just go back to your TVM solver, plug in the variables, solve for your unknown. And there's your solution. It should be 998.67 once you put that in your solver. Again, the rest of these problems, basically, it's similar as far as putting in the calculator. You just got to know what to put for your n and so forth and so on. So here, number 3, you're making $80 monthly payments every month, 6.3% interest compounded quarterly for 7 years. How much do you have at the end of the term? Again here, what's my end value? End value is quarterly for 7 years. So it's going to be 4 times 7, which is 28. Interest rate is 6.3%. It's given. Present value, there's no present value, so that's going to be 0. Your payment will be your $80 payment, and it's going out as a negative value. Your future value is what you're solving for. And payments per year, that's going to be quarterly. And then you just solve for your future value. And there is your solution, $2,788.21. Alright, number 4. You already have $1,000 saved, $10,000 saved in an account, and plan on saving $300 a month for 10 years. How much will you have at the end of the term? Let's see. You're in 10 years, and we are, I didn't specify. So I believe this one was monthly, though. It was. This one should be compounded monthly because we're going to do $300 a month. But you don't assume that, but it is monthly. So it's going to be 12 times 10, which is 120. Your interest rate is 6%. I didn't type that in the problem. That was my fault. Sorry. But the interest rate was 6%. Should have been given up here in the problem. Present value is 10,000. The main thing here, your present value is going to be negative because there's money outflowing, and your payment also is going to be negative because that's money outflowing as well, which is negative 300. Future values, what you're looking for, payments per year, compounds per year, that's 12. And then you're going to just solve for your future value. And there's your solution for number 4. Alright, last but not least, this one works the same principle as house and car payments. We have $850,000 in your retirement account, which has an interest rate of 4.8% compounded monthly. You will withdraw $4,000 every month until it's depleted. Let's see, our N in this case is going to be unknown. My interest rate will be 4.8%. And let me pause so I can type in all the information for you. Okay, here's the solution written out. Basically, only difference with this, your present value is a negative and your payment is a positive value. And you're actually solving for N here. Once you have your N value, you're going to take your N, you're going to set it equal to payments per year times the number of years divided by 12, and it'll give you about 40 years. So basically this amount of money will last you about 40 years until it's depleted.